Good afternoon, everyone, and welcome to today's webinar on how Megaputer's flagship data platform, PolyAnalyst, handles integration and automation challenges. PolyAnalyst is an interactive no-code platform which allows data extraction, transforming and loading ETL, analysis of structured and unstructured data, and creating beautiful dashboards in an integrated interface. Today, we will see how PolyAnalyst integrates with the software environment of an organization. For more information on PolyAnalyst, please check out the videos, webinars, and tutorials on our YouTube channel, youtube.com/Megaputer. PolyAnalyst helps address the challenges that come with complex and continuously evolving software ecosystems within an organization. For example, data can be siloed, creating barriers to efficient access to the data. It can create inconsistencies and discrepancies in the data, which can lead to incorrect results down the line. Data compatibility issues often arise when different systems use different data formats or structures, making it challenging to seamlessly transfer and utilize data across platforms. So, integration becomes essential to bridge the gap between incompatible systems. The system needs to have appropriate input and output connectors to be able to be a component of the data pipeline effectively. Various components of the data pipeline, such as ETL modules, machine learning models, and dashboards, may exist as separate services or platforms with different access protocols, credentials, and interfaces. Integration becomes crucial to harmonize between these components. Integrating large volumes of data or supporting high transaction volumes can lead to performance bottlenecks, latency issues, or scalability limitations. Integrating systems introduces security risks, such as unauthorized access, data breaches, or compliance violations, particularly when sensitive or regulated data is involved. PolyAnalyst has features to meet all such challenges in an organization's software environment. To illustrate some of these capabilities, we will create a quick project in PolyAnalyst. The scenario is this. We are creating a recommender system for a car rental company. This company added various car models to its fleet over the years, and based on their experience, they identified some car models which worked well for them. Now they want to add cars from 2023 and 2024 to their fleet and wish to identify car models suitable for them based on their past experience. As parameters of this recommendation system, they wish to use various ratings provided by the National Highway Transport Safety Administration, or NHTSA. So for building this system, we will look up the NHTSA ratings for the car models in this company's database using the NHTSA API. We will build a machine learning model with these ratings as parameters and evaluate the 2023 and 2024 car models for a good fit with the company's requirements. So let's go to the interface of PolyAnalyst. So this is the analytical interface of our platform PolyAnalyst. It is designed to be a flowchart interface where um, different modules can be dragged and dropped onto the flowchart and connected with each other. And the data flows through this analysis scenario, and the data flow is shown by arrows. So coming back to our problem, um, first we will see which car models are already there in the company's database. So the company uses a legacy database which has an ODBC connector. So we will connect to this ODBC database using an ODBC source module, or we call these modules nodes. So here we have a list of car makes, models, their model years, and whether or not the company thought it was worthwhile to buy this model. So they thought that Chevy Cruze 2015 was a good fit for the requirement, same as Chevy Impala, yeah, EcoAssist 2015, and so on. So we have a number of models here which they see as a good fit for their requirements. Now we need to get the different ratings provided by NHTSA for each of these car models in order to build our machine learning model. So I need to connect to the NHTSA API. So in order to make an API call, I need to derive a URL. So for this, I will use a module called derive. And I will create a new variable called URL. So NHTSA's API needs you to first find out the vehicle IDs, and you can look up the various ratings by vehicle IDs. Um, so now I will use a REST API node in order to connect to NHTSA's API and download their data. Maximum delay I will set as, and the URL will be URL field. And when I execute this, now my REST node is querying the NHTSA REST API. So connecting to REST APIs is pretty much as simple as this. Now, there are a few steps involved in order to download all the ratings from NHTSA. So I have that already configured. So in the first step, I get the vehicle IDs. In the second step, I get the vehicle ratings. In the REST API nodes, we get the API responses, and in the following nodes, we parse those API responses, key value pairs, and extract the actual data. So our final data looks something like this. So we have the makes, models, and model years, and different types of ratings. Also, we have the NHTSA electronic stability control availability, um, whether or not forward collision warning is available, or whether or not lane departure warning is available in these vehicles. So we have various ratings such as overall front crash rating, the overall rating, the overall side crash rating, rollover rating, um, side crash driver side rating, side crash passenger side rating, and so on, a number of them. So we will be using these ratings and these three parameters in order to build our machine learning model. So I will put these aside and join the ratings to our original dataset. Now I'm going to build uh, um, a machine learning model using PolyAnalyst Python classification module. So my target column is whether or not to buy a car, and my independent columns will be these three NHTSA ratings and the rest of the ratings. Now in the options tab, I will select which model I'm going to use. So I'll go with decision tree in this case and set a few parameters. So I'll go with chi-square for feature selection, and for result validation, I'll go with cross validation and execute. So this is um, creating a decision tree model for me. Uh, I can check how this model is behaving, um, the ROC curve, lift curve, gains curve, um, confusion matrix. So we have um, around uh, 24% false classification. So I think we can use this model. Now, my the company has provided me with a list of uh, car makes that they want to consider to include in their list, include in their fleet from 2023 and 2024. So we have 2023 and 24 models of Ford, Toyota, Chevy, Honda, Hyundai, Volkswagen, Subaru, and Acura that they want to consider for their fleet. So now I need to import this file into PolyAnalyst and figure out uh, figure out the NHTSA ratings for different models of these manufacturers. So importing a file into PolyAnalyst can be as simple as just dragging and dropping the file onto the flowchart. So I drop the file here and run the file, and we have the file here. Now, similar to when we figured out the NHTSA ratings for known car models, we also need to figure out, or we also need to download the ratings for our new car models. So I also have it. I also have done it because downloading it from NHTSA may take a little while. Now I need to run this train model onto my new car models, and for this I will use the score node. Score node runs a train model on a new data set. So I'm going to create a mapping of the training columns and the final columns and execute. And here we see that the decision tree has created its recommendations. So py underscore by is the recommendation created by our machine learning model. So when it says yes, it means that the machine learning model, the decision tree model says that this car may be a good fit to buy. So let me filter out only the ones which are recommended by the machine learning model. So wherever PIY by has the value yes, so it recommends 29 models for potential inclusion in our fleet. For example, Ford Bronco Sport, Ford Edge, Ford Escape, Ford Expedition, and so on. Now, suppose that I want to get some quick information about these models. So in this case, mm, the large language AI models, they can be a good source for getting a quick summary of each of these models. So I'm going to query ChatGPT right within this interface for um, for a quick summary of each of these models. So I will use a module called AI Assistant. So I will need to ask it a question, and the question will look something like this. Give me a brief overview of the features of the car make, followed by car model produced in the model year. So it will look something like, give me a brief overview of the features of Ford Bronco produced in 2023. And this will be the query which I will send to the GPT 3.5 Turbo model of ChatGPT. There are other queries that we have already configured in this AI assistant module. For example, summarize, entity extraction, tonality analysis, translation, paraphrasing. So these are all the possibilities that you can explore in this node. I will go for a custom question in my case. So execute. And now the system is querying ChatGPT for an overview of the features of each one of these models. It may take a few minutes to cook. So in the meanwhile, we can look at other some other features of PolyAnalyst. So uh, one big integration aspect is whether or not your system is able to communicate to a programming language. So PolyAnalyst has a Python and JavaScript API. So let me quickly demonstrate the Python API for you. So in the Python interface, we need to first import the PolyAnalyst 6.5 API module, and we can connect to a project by creating an instance of this PolyAnalyst 6 API class. We pass the link to the server on which PolyAnalyst is running, the login password, and then we connect to our project using its project ID. So mm, so suppose that I want to see I want to export the contents of this modify columns node and access them through Python so that I can pass them on to some other system. So I can simply access this data set by giving the, uh, the name of the data set, which in my case is modify columns, and I'm going to get this data set in the form of a JSON string, which can be forwarded to other systems, or it can be used to make API calls to other systems. Now, the same API can also be used to parameterize some selected uh, points in our analysis scenario. So, for example, at suppose that at runtime, uh, my the user wants to run only the compatibility of say Ford models. So I need to filter out uh, 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 only the Ford models at runtime. So I can use the filter rows node interactively and say I want the make be 4, execute, and I can run the model only on these few Ford models. But this is an interactive um, uh, this is an interactive interface. What if I want to do it on runtime using the programming interface? So the PolyAnalyst API allows you to do just that. Let me rename this node to something tidier. So only filter rows. So the API allows me to modify what expression goes into my filter rows node. So I set it to the filter expression being make is equal to 4, and I communicate this expression to my filter rows node using a special node called the parameters node. So this parameters node is the conduit between different modules of PolyAnalyst and Python. So Python will talk to the parameters node, and parameters node will talk to the filter rows node. So going back to my no, first I'll need to tell the parameters node that it will be working with filter rows. And see, okay. Now my node name is simply parameters. It is talking to filter rows node. So I will execute this parameters node and see what happens. So we see here that the parameters node read the condition that we put into Python, and it passed on this condition into my filter rows node. So instead of 4, uh, I can choose to make it Ford and Chevrolet, and I will execute this again. So the parameters node will be updated. I will freeze this module so that it doesn't keep executing with um, every selection. So here we see that the new condition has been transmitted to the parameters node, which has been transmitted to filter rows node. So this is the way in which the analytical system talks to programming languages. It can exchange data with the programming language, or uh, it can receive runtime parameters from the programming language, and which allows closer integration between the software environment and PolyAnalyst. We can quickly see one more example of how parameters node can be used to parameterize runtime settings. So suppose I want to export this data set to a file. In that case, I'm going to use a node called export to file, and maybe at each runtime I need to create a new file. So for that, I will use another parameters node, which is going to talk to this export to file node, and it will tell the export to file node where to put the data that it just produced. So let's go back to Python, and this new parameters node is named parameters 3, and it is going to talk to export to file. So that is all the setting that we need that I need here. So I'm going to say I want to configure parameters 3, and I can give it a file path and name. So D drive, local data, employees, B number, car model recommendations 2, and the extension is XLSX. So it's going to export um, the recommendations to this file, which will be an Excel file, and then I'll execute this parameters node. So let's see how this execution works. So the settings from Python went into parameters, which then further went into export to file, and we have the file exported with the specified file name into the specified location. So here we saw that the different uh, the different types of integration features that PolyAnalyst has to offer. So we can interact with legacy platforms using ODBC and OLEDB interfaces. We can interact with file systems. We can interact with AI, data pipelines like APIs or machine learning models, and we can interact with programming languages. There are other features of PolyAnalyst which can be used for improving the integration experience even more. So the PolyAnalyst workflow that we just saw, it can be turned into an application which can be accessed through a REST API, and it's the application builder functionality of PolyAnalyst. Then PolyAnalyst allows granular level of collaboration between different users. Users can be given read or edit access to the analytical workflows or to dashboards, um, or to other resources such as dictionaries and ontologies. And also, PolyAnalyst comes in another flavor. It's called the PolyAnalyst Grid, which is designed for big data capable of handling billions of records and several gigabytes of data. So this allows processing of large scale data using PolyAnalyst. So this concludes the overview of integration and automation features of PolyAnalyst. Thank you, everyone.